Hi students, let us start with chapter 21, Trigonometrical Identities. So, coming to trigonometrical identities, previous year we have already learned about our trigonometrical ratios. We have learned what is sine, cosine, tan, cotangent, secant and cosecant, right? So, similarly, we already learned about the reciprocal ratios also in the previous year. Let me write down that. What are the reciprocal ratios? We know that sin A is equal to 1 by cosec A. Similarly, cosec A is equal to 1 by sin A. Cos A is equal to 1 by secant A, and secant A is equal to 1 by cos A. Tan A is equal to 1 by cot A, and cot A is equal to 1 by tan A. So this relations we'll be using while doing problems. Then we had the quotient relationship also. What is the quotient relation? That we'll be coming to that now. What is sin A? Sin A is equal to perpendicular by hypotenuse, right? And cos A is equal to base by hypotenuse. So when I write sin A by cos A, what do I get? I get perpendicular by hypotenuse by base by hypotenuse. So my hypotenuse will get cancelled. So finally I'll get perpendicular by base. Which ratio gives you perpendicular base by base? That is tan A. So I get sin A by cos A is equal to tan A. Similarly, I can write cot A is equal to, cot A is 1 by tan A. Reciprocal of that will be cos A by sin A. So in order to solve the prove the identities here, we will be using all this relation. Then coming to next is square relation. What is square relation? So if you have a triangle like this, I consider this as triangle ABC. So the right angle triangle ABC, B is the 90 degrees. So sin A will be what? Sin A will be equal to BC by AC, and cos A is equal to AB by AC. For A, the base by AC, hypotenuse. So if I take sin square A plus cos square A, I get BC by AC the whole square plus AB by AC the whole square. So BC square plus AB square by AC square. What is BC square plus AB square? That gives you the hypotenuse, right? So BC square plus AB square is AC square. AC square by AC square is equal to 1. So you get sin square A plus cos square is equal to 1. That is one identity we are getting. Sin square A plus cos square A is equal to 1. Okay. Similarly, we have more. Similarly, I can write 1 plus tan square A. If I am writing, I can write as 1 plus tan square A will be BC square by AB square. BC by AB whole square. That is equal to this AB comes here. So AB square plus BC square by AB square. That is equal to AC square by AB square. What is AC square? That is hypotenuse by AB base. What is hypotenuse by base? Hypotenuse by base will be your secant A. So you are getting secant square A. So you get 1 plus tan square A is equal to secant square A. Similarly, if I solve, I will get 1 plus cot square A is equal to cosecant square A. Okay, so you are getting these three identities. With these identities, you can remember 9 identities. That's there near page number 320. Page number 320 is given in a box as a note. So you need to learn that. Using all these things, you will be solving this given identities. So how to solve it? It's in page number 321. In order to prove a given trigonometrical identity, start with any side, left hand side or right hand side, and by applying the trigonometrical relations such as to the other side, if you start with LHS, reach to RHS, or if you start with RHS, reach to LHS. Okay. So in general, start with the more complicated side. That will give you easier way. So let me start with the exercise. So when we do more problems, it will be clear to you. Starting with exercise 21A. Let me do a few questions. So coming to the first question, prove the identities. Secant A, first one is secant A minus 1 by secant A plus 1 equal to 1 minus cos A by 1 plus cos A. We need to prove this. So this is my LHS and this is my RHS. So let me take LHS first. LHS gives you secant A minus 1 by secant A plus 1. So you need to get back this 1 minus cos A form. You already know that secant A is 1 by cos A. So that is equal to 1 by cos A minus 1 by 1 by cos A plus 1. That's equal to 1 minus cos A by cos A by 1 plus cos A by cos A. Cancel them. You get 1 minus cos A by 1 plus cos A. Did we get back the RHS? Yes. So you can write hence proved. You started with the LHS, you reached back the RHS. Hope it's clear. Now coming to the second question. 1 plus sin A by 1 minus sin A equal to cosecant A plus 1 by cosecant A minus 1. Okay. So 1 plus sin A. So again I'll take the LHS. 1 plus sin A by 1 minus sin A equal to 1 plus 1 by cosecant A. Sin A is 1 by cosecant A. So you can just see what to apply. You have to see the LHS and RHS and compare and do it. 1 minus cosecant A. So taking LCM, I get cosecant A plus 1 by cosecant A by cosecant A minus 1 by cosecant A. So this and this I can cancel. Finally I'll get back cosecant A plus 1 by cosecant A minus 1. That is equal to my RHS. So again, hence proved. So these questions were similar. So you could easily do it. Now coming to the third question. Question number 3. We have a different type. 1 by tan A plus cot A equal to cos A sin A. Okay. So let me start with the LHS itself. Complicated part. It's better to start with complicated. So complicated part is the LHS. 1 by tan A plus cot A. So we want the answer in form of cos and sin. So we know tan and cot can be written in form of cos and sin, right? What is tan A? Tan A is sin A by cos A. We had already proved it, right? Plus cot A is cos A by sin A, right? So this will be equal to 1 by cross multiplying, okay? Sin square A plus cos square A by cos A sin A. 1 by cos A sin A. Why is it 1 by 1? We already know that sin square A plus cos square A equal to 1. So this will go up. So finally what I get? Cos A sin A will be the answer. What is that? What I need to find out here? That is my RHS. So hence proved. Hope it's clear to you all. So now coming to the fourth question. Fourth one. Tan A minus cot A equal to 1 minus 2 cos square A by sin A cos A. Again you can see that tan and cot is there, you need a result in form of cos square A by sin A cos A, sin and cos. So let us apply the same thing. So let me take the LHS itself. Tan A minus cot A equal to, what you will get? You get it as sin A by cos A minus cos A by sin A. So cross multiplying, I get sin square A minus cos square A by sin A cos A. Correct? So sin square A minus cos square A by sin A cos A. So I need the result in form of denominator is same. I got the denominator same. Let's look at the denominators. It's same. Only numerator I need here 1 minus 2 cos square A, but I have a extra sin square A here. So what do? I can take, we already know that sin square A plus cos square A is equal to 1. So what will be sin square A? Sin square A alone, if I need, I can write as 1 minus cos square A, right? So replace the sin square A with 1 minus cos square A minus cos square A by sin A cos A. So that is equal to 1 minus 2 cos square A by sin A cos A. Look at the result. So it's equal to our RHS. So you can write hence proved. So this is the way you will be solving all the questions in this exercise. You have to, there is no particular formula or method. You're just looking into the question and finding out which identity can be used and or which relation can be used, and you are putting over there and solving the problem. Okay, so please go through the identities, that is sin square A plus cos square A is equal to 1. Explanation is given in your textbook. Please go through that, and all the 9 relations also you need to learn that, so that it will help you to do the problems. Thank you, students.